OFCnet allows the corporate members of Optica to have access to a real telecom and datacom infrastructure so they can prove their customers their technology works at the highest level of their potential. I'm here to see all the different companies that are using OFCnet in 2025. One of them is a company market leader in QKD, the company AUREA. I'm here with the CEO of AUREA, Jerome Prieur. Jerome, you brought to OFC 50 to OFCnet a QKD demonstrator. Why did you choose this platform?
Oh, OFCnet is amazing. We tried this platform last year. This is the only platform where we can demonstrate in live entangled distribution. So here you have our device, which is an entangled photon source connected to a fiber, and this fiber is connected to our booth, where we can demonstrate the quality of our quantum communications.
You can see the fiber going all the way up into the sky and following, and here it comes down and arrives into your demonstrator as a corporate member of Optica. Show us the booth.
So I give the mic to Dylan, he's the engineer working on the demo.
Dylan Legag, thank you very much for having us. What are we looking at?
Thank you very much. So the fiber is coming here, and we're detecting the entangled photon using two single-photon detectors. Up to now, we're able to then detect the timing arrival of the photon using timing correlating units, and therefore could estimate somehow, we could retrieve the state of the photon, be sure that they're really twins, and probably generate an estimated SKR, so a secret key, between two users, for example. So this is all about this distribution of entanglement.
You're using 5 kilometer or a standard telecom single-mode fiber.
Exactly. We do use Corning to 5 kilometer SMF fiber, yeah.
And what you can see here is that you're using a bit rate of 700 bits per second. Why?
Yeah. Well, at least it's here is to demonstrate the possibility to, for example, if we had the modulation unit, we could achieve 700 bits per second in terms of key rate. Yeah.
For doing the detection, one of the things that sets your company apart is that Bob uses an SPAD. How difficult was for setting up this demonstrator using OFCnet and with the SPAD of Bob?
Yeah, we do actually use SPAD in the very tiny box here because it's very convenient. It's working at room temperature, do not any cryogenic cooling, and the performances are really good. We could achieve very low noise with the SPAD technology, and that's very nice.
Jerome, you had this working with a standard telecom fiber, but given the simplicity and, of course, the resilience of your technology, you have managed to take this also into space, correct?
Exactly. We work on a space program with the European space agencies. The idea is to use our entangled photon source in space, so on a satellite, and to communicate to two optical ground stations by using our technology. Actually, we are introducing a very fast technology at a gigahertz here. So this is a very new technology. We are the first worldwide to release a gigahertz photon counters, and this is used for space programs.
So seeing the technology already deployed in space, and you were chosen one of ESA's rising star, what is the space future for AUREA?
Okay, we think the future of quantum communication, we believe, is going to be on space. So we are investing with the European community to really deploy this technology. So this is for us the future.
How is it different to deploy QKD in space than to deploy it using a standard telecom fiber in a terrestrial network?
Very good question. On Earth, the limitation of the transmission with quantum communication is, let's say, 150 kilometers. With the space communication, we can reach thousands and thousands of kilometers. So it means we can build up a network all over the world.
You have made big investment on having very stable entanglement sources. How do they perform in space?
Yeah, so entangled photon sources have been proved to work in space. We are still developing the technology, and we believe that the SPAD technology will be deployed on the optical ground station.
What is the next stage?
It's to reduce the size. Mainly, it's to reduce the size.
So let's play the crystal ball game, Jerome. It is OFC 2030. You and me look the same. Maybe a bit older, but just a bit older. How does AUREA Technology look like in OFC 2030?
Okay, so we will get more compact product, definitely faster, and also with lower noise. This is the future in the next 5 years.
Faster and lower noise.
Yeah.
Congratulations for everything that you are achieving. I look forward to seeing you equally young at OFC 2030, faster and with lower noise. Thank you very much.
Take care. Thank you very much.